Is that from marketing?
Oh yeah, it's actually a good one though, so that's why I'm putting it in.
Are they trying to get more senior and principal engineers?
Uh, there was a where is? Oh no, that's right. It got closed down. Because I restarted the computer. Ion. Because they sent me this.
Well, that's cool. Are you going to go to that?
Probably not.
Okay.
It happened yesterday, so.
Oh, I didn't even notice. Okay.
But let's talk about this after your topic. Actually, let's talk about this at the end. Oh, this week during the gaming, we need to talk about like the contest.
Oh, okay. Yeah. Also, we need to talk about the crab or the crawfish boil.
Yes, because I need to take my time off if that's going to happen.
It's happening.
Okay.
Yeah. No, it's even if you weren't to show up, it's still happening.
Okay. No, that means I need to take the Friday off then.
We found an Asian mart actually just up the road that gets fresh deliveries of sacks of crawfish on Tuesdays and Fridays. So we're gonna go on Friday and get us a bag of crawfish.
So
I know at least some of the people from my engineering team are gonna show up.
you might need more than one sack then.
Well, okay, so
How much
I'm
is a sack are they selling it for?
how much money?
Yeah. What's their
I
per
think
pound?
it's $5 a pound or something like that.
I mean, given you have to get it all the way from basically Houston / Louisiana all the way there.
It's gonna be more expensive here. Yeah.
I paid $1.99 like a couple weekends ago, and I'm like, it's gotten pretty inexpensive now. Which it used to be like during the pandemic, it was like $3.50 a pound, and I'm like, but I will throw in dinero as well.
I think right now so far we have 12 people coming. And it could be up to like 17 to 20 people.
Yeah, 20 people is going to be, I'll put this way, pushing it for one sack.
Okay, so they said the sacks are somewhere between 30 and 40 pounds, and you can say like, give me one that's closer to 40. I think that's what we need to do.
Yeah. I'll put it this way: the worst case scenario is running out.
Yes, yeah. And if we have extra, I'll peel them and freeze.
That's the thing. There's nothing wrong with just buying more.
Yeah, 100%.
So,
So I'm gonna err on the side of caution and get more, but we'll have all the sides and everything like that.
yeah,
So.
it's just one of those like, it's better to have more, and have extra left over than
Agreed.
we run out and people are still like, I want more.
Yes.
Because you can be surprised how much like what ends up happening is like someone like me shows up and eats like 5 pounds.
Yeah. So my buddy who originally asked to do this with me, he was like, "Yeah, let's get 30 pounds." He's kind of like antsy on getting more, and I'm like, "Nah, dude, more."
Yeah, like I'll throw some cash down just for like to cover my because I know I'm going to eat a lot. So
Yeah. No worries. I kind of wanted to make it a thing. So feel free. I mean, if you're flying, you can't do much, but feel free to bring beer. I'm actually doing a beer trade with my buddy in Texas. We're both mailing each other beers this weekend, so I'll be getting Texas beers up, and I'm shooting him Colorado beers. But don't feel like you need to bring anything. But if you want,
no, I was going to bring some beer.
Okay.
There should be like a beer It's actually like wine luggage. My
Yeah.
parents have luggage for wine.
I've
And
seen your mom's collection.
yeah. Though I have I brought beer to Colorado with that before. I brought Joe a whole bunch of his favorite Austin beer.
Nice. Have you been out to Baba Brewing? My buddy sends me Baba every time I ask for it. It's out in Sealy, so it's
Okay,
out west.
that's not too far.
No, it really isn't. It's like a go on a Saturday kind of thing. But their beer is awesome. Like, and they do a bunch of weird stuff and random stuff. But everything I've had from them has been really good.
Yeah, I might have to take my dad out there.
Do it. Like they do some stuff that's like full on like fruity, not like a hazy, but like a fruit beer.
Yeah. Oh,
But then they
okay.
have a bunch of regulars, and it's all really good.
Because I'm thinking about going camping again coming up. That might not happen though, because the trip to Denver. But I've been thinking about like camping because there's a lot of like little tiny breweries that are like in the middle of nowhere in Texas.
Yeah.
And a lot of times there's lots of little campsites, like private campsites that are right near that area. So basically, like do like a weekend, go camping, and then go to hit a couple breweries in the area. My problem with my red Jeep is it's perfect for camping minus one thing. It does
What's
not
that?
have enough space for firewood.
Oh, well, you can get your own out there.
Well, a lot of times you go to these places and they're kind of picked clean.
You just get a bunch of little sticks this size.
If you can find stuff that's that big. Yeah, so I guess I can put a basket on the back.
You have a trailer hitch. You could probably get one of those ones that just plugs into the trailer hitch.
I mean, I have one of those.
Oh, well, there you go.
Yeah. I can just put it on the basket, I guess. But I have everything, like, actually contained inside that Jeep, which is kind of impressive. Just no firewood. I guess I can put the firewood in the footwell on the passenger side, because King doesn't use that area.
There you go.
Because King...
Glove compartment.
Yeah,
like
just
a
full
log
of
in
firewood. Yeah, because I bet you I can put a 5-gallon bucket there full of firewood. If I cut it, all nice straight pieces.
Mm-hmm.
Yeah, I guess I need to share this link. Oh, next week we have our first meeting with our like podcast firm thing. That's like taking a look
okay.
at the analytics and stuff.
Yeah.
See what they can do.
Cool. When is that?
When is that?
Mm-hmm.
Next Tuesday.
Cool.
So that's gonna be interesting.
Yeah, they're gonna just have some initial data for you.
Yeah. I'm looking
Cool.
forward to it. See if there's anything like above and beyond what we already know about it.
Anything that just stands out as,
Yeah.
high or low numbers. I wouldn't even know how they gather information.
Yeah, that's going to be the interesting thing is seeing what they come up with.
You never know. Maybe you get into that meeting and they just don't have any information whatsoever.
I hope. I'm
I mean, if that
paying
happens,
them
then
to
like,
do it.
yeah, that would be like a hey, get out of here kind of situation. But you never know.
Yeah.
They may.
Well, we interviewed a lot of like these podcasts, like firms and stuff to help. So
Oh, did you just turn off your AC?
Yep.
Okay.
I just get super quiet.
Oh yeah. Yeah.
I wonder if I should. Can you still hear me?
I can.
Am I quieter?
A tad.
I'm much quieter on my meter and obes. Blah 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 blah. That's probably way better.
You're a bit spicier now.
There you go. Keep it spicy.
There's a tiny bit of background noise now.
Let me just turn the fan off because you're probably hearing that click click click.
No. Well, turn it off. We'll see. No, I'm hearing something high frequency, but not like a single pitch. It sounds electronic.
That's the computer itself.
Yeah, I can. It sounds like a
fan.
case fan. Yeah.
Yeah. I knocked it one notch down.
Yeah. It would be really hard to tell.
Okay, we'll just leave it how it is.
Yeah.
Woo. You see that the picture I sent you?
Oh, of the lights on your car?
Well, there's that one, but the first picture, I got the old onboard air system that I used to have on the red Jeep.
Mm-hmm.
I put that on the truck.
Nice.
So you can fill up your tires and that kind of good stuff. Run air tools.
Yeah. What do you pressurize that tank to?
200 psi.
Wow.
Yeah, the whole system's a 200 psi system.
Wow, that's pretty hot.
Yeah, especially with no regulator.
Oh, it's just raw 200?
Yeah, it comes right out of that quick connect. It's 200 psi.
Jeez. So if you disconnect it, it's probably like pow.
Yeah, pow. Yeah, but it works great. That system was really nice on because the 200 psi running like an impact gun was pretty rad at 200 psi.
Let me grab something real quick. Lauren and I are using the crawfish boil as an excuse or a motivator to clean the garage.
Mm-hmm.
And like we used it as a dumping ground for 4 years. And now we're like, we can't do that.
I do remember when I was there and just how many cardboard boxes you had in there.
Well, those were our moving boxes.
Yeah, but they were still. I guess that was only like a year after you moved when I came up.
Oh, that was half a year. Because we moved in November and you came in the summer, so
That's right.
But still, yeah. Like, let's put it this way: it never got better until now. But anytime you clean your garage, you find tools. Like
Okay.
they find boxes. I totally forgot that I have this like crazy like all metal body impact.
Oh, that thing's cool looking.
This thing is legit, dude. I forgot my dad bought me this a long time ago. This thing will outlive me.
Yeah, you can now run it too with your compressor.
Yeah. I was like, God dang. I don't need a project, but I kind of want a project to use this on now. Just because it's like, oh yeah, I have that.
I'll say it took me a long time to finally get an impact gun.
Yeah, they're nice.
Yes, finally getting a air impact gun for automotive use. I was just like, where Why was I like
Why did I hesitate?
hesitate not getting one of these
Yeah.
like forever? Usually that happens with tools though, for me.
Oh yeah. Once you get it, you're like, oh my god,
Yeah, why? Where has this been all my life?
dude. Like it's like, god dang, dude.
I like how chromy it is.
Yeah. I mean, it had a whole bunch of dust and crap all over it. Now, when you get here, you'll need to handle this thing. Oh, it's nice.
Yeah, because mine is a an air cat model, so it's got like overmolding and stuff all over it. Which
It's got spaceship.
yeah, it looks like a transformer.
Yeah, freaking AVE always talks about that. Like, in my opinion, the overmolding stuff doesn't add anything to your product whatsoever. Like,
No.
it doesn't make it look cool. It doesn't make me want it anymore.
No, I did pick this one because it does have the highest reverse torque rating out of all of them, though. It's
If that was a if that was a Harbor Freight tool, they wouldn't call it reverse torque. They would call it like blast torque or something like that.
blast processing torque. I really like that impact. Like basically, that impact is that I have is it is either coming apart, whether it likes it or not. It's either basically gonna the bolt will come off or it will just shear.
Something is gonna win, and the impact gun is always the something.
Yeah. The impact gun always wins, which is really nice because it's like basically if you can't get it off, like you can't unbolt it, you're gonna have to break it anyways to get the whatever it is apart.
Yeah.
So it's a great way for it just to shear it.
Oh, it probably pulls heads off, no problem.
Oh yeah, I think the biggest thing it's twisted apart was a 1/2-inch bolt.
That's a beefy bolt.
Yeah, especially for a 1/2-inch drive.
Yeah, it's a great way to cam your ratchets
Yeah,
or your sockets. I mean,
yeah. Well, I was using it impact rated, so it was all fine, right size.
like,
But that was a
super
U-bolt.
hardened and stuff.
It was a U-bolt on the rear axle of the checker. Actually, I take it back. That's a 9/16 bolt. It's sheared.
Okay, 0.55 or whatever.
Yeah. Well, it's probably a grade 5 too, because it's a U-bolt.
0.56.
So it's not like it's a grade 8 or anything like that. But yeah, it just like those U-bolts are 60 years old of rust, holding them into place. And I first tried to like use a breaker bar, and I couldn't even get a breaker bar to move them. And I'm just like, okay, let's just try the impact for like 30 seconds, and then it went and just threw the bolt through the lug. Yeah, but having because that's only running at 90 psi. I can't imagine running that air gun at 200 and how much reverse torque it would have. Probably can't run it for
Wow.
long.
Have you seen these tension indicating headset screws or head screws?
Yeah, where they have like a little indicator inside of them in the head.
That's super cool.
Yeah, and how they work is it's like that bar inside is like a fixed piece, and it's physically moving closer to like the head bolt.
And there's like a lens on the top.
Yes, to magnify it so you can see it.
I mean, makes sense that they're $26 per.
Yeah.
Still, that's pretty freaking cool.
Yeah, they're very limited in application because a lot of times it's like you would just torque it with a torque wrench and it would be fine.
I wonder what the tolerance is on all of it, because I mean it's just going based on color.
Yeah, I wonder. Yeah, I wonder what it is. Torque indicating bolts.
Yeah, McMaster has grade 8 torque indicating bolts. That's pretty hardcore.
Plus minus 10%, which is oh no, that's just torque normally. Tension indicating fasteners is what it's called.
Mm-hmm. Well, I mean, it's tension because that bar moves as the bolt stretches.
Mm-hmm.
But I mean, the amount that the bolt stretches is not a whole lot, so it's got to be really pretty tight.
Direct tension indicating fasteners, DTI is what it's called.
Down to indicate.
Okay, so the reason why you use these is so you don't have to check the torque during maintenance cycles.
Oh, you can just look at it.
You
and
can
know
just
it's good?
you can visually look at it and see if it's torqued or not.
Is it repeatable? Is the question. Can you unseat it and it goes back to being red or
I
whatever
think
color
so,
it is?
actually. Last time I looked at these a long time ago. Just because I was like, they're just fascinating.
Yeah.
But like, there's a white paper that the company that makes them called Smart Bolts has. Let me push this in chat. But like, one of the ones is like on like a machine that has like every 6 months you gotta check the torque. It's like, well, instead of having to bring the machine down to
You
check
can
all
just
the
look at them.
and to check the torque, you can just look at them with a visual inspection. And
That's neat.
so they have like a price breakdown of that.
So combine one of these things with Nordlock washers, and you have something that will never, ever, ever come apart.
Yeah, never to come apart ever again. They are quite pricey though.
Yeah. Yeah.
Interesting for using them for hold down bolts. So they're definitely reusable. So instead of using like if you're doing really precision machining, you like torque down your fasteners so that you keep everything flat. So instead of having to have a torque wrench every single time to do that, you just turn it until the head of it turns black. So yeah, I wonder what the tolerance is on these. I could definitely see this is for like inspections though. I mean, like for my suspension on the Jeep, I had to basically every year I had to check the torque on all the bolts.
Yeah, I'm actually planning on doing that on my dirt bike before riding it. I'm hoping to get it out this summer,
Yeah.
but yeah, I'm hoping to. I'm not hoping. My plan is to go bolt by bolt and just make sure that everything's fine because I can't tell you the last thing that thing's been ridden.
Okay, I actually found it. DTI Smart Bolts, registered trademark, are accurate to within plus minus 10% of design tension. Stress indicators also have a new precision product called HR Smart Bolt, which is the high resolution, which is plus minus 5%. So, yeah, that's about the normal range of like, a 3% torque wrench plus, the human not turning it past a click. Usually you get plus minus about 10%.
Apparently, there's also there's DTI washers as well that have like raised indentations on them, and and those indentations crush under a certain load. So you turn it, you see the washer crush, and then you know that represents some load.
Stress value.
Yeah, yeah. You know you're torqued to some level. That's neat.
That is interesting. I wonder if those are probably not reusable.
Oh, okay. So with those ones, what you do is you torque it down, and then you use a feeler gauge, and depending on the height or however much it has crushed those little protrusions, that's your torque.
Huh. That doesn't seem to be as good as the bolts.
But it's probably a lot cheaper.
Well, I'm just saying from a speed aspect. It seems like the whole point's the speed aspect.
Yeah.
Of like applying the fasteners. Or like just inspecting it. Like visually inspecting.
I think what you mentioned earlier is exactly it. It's not a speed of installation. It's a speed of checking later down the road. Yeah.
The only other one that's speed is machining operations. Securing work pieces down.
Right.
Because then you don't have to have a torque wrench. You can just use a box wrench to do it.
Do they have a fixed torque, or can you buy them to whatever torque you want?
I think you can buy them to whatever torque you want.
Oh, okay. That's cool.
Smartbolts.com.
Because if you get to specify the torque range, that would be legit.
Request pricing.
I never really studied bolts very much, so I guess I never understood. I mean, just the other day I watched a video on bolts and tightening and things like that, and I didn't really ever know or put together that the way a bolt actually holds things together is via stretching. Like
Yeah,
it
stretching.
actually stretches, and that puts it in tension, that holds it.
Yeah.
I thought it was. I guess I never really put two and two together that it literally deforms.
Yeah, you start going under elastic tension, basically.
Right. And which is a pretty small range for a bolt, but as long as you stay within that elastic curve, then you can unloose it and, return.
Reuse it and stuff.
Yeah.
What you should really look at is like the torque ranges of fasteners, especially smaller stuff like quarter 20 that you probably use a lot of. You've probably been over tightening quarter 20s all your life.
Oh, you can easily do it by hand over torque.
Yeah.
Like I was looking at M3 for mounting
M3's tiny though.
but M3 for mounting TO220 transistors to a heatsink. Just the little tab. It's like 2 to 4 Newton meters. I don't remember exactly, but it's small. It's really small. And in fact, what's interesting is before you get to the ultimate strength of the screw head, you actually get a problem with TO220s where you tighten them so much that the body actually lifts from the heatsink, and then you completely defeated the entire purpose. Because now you're not even making contact with the heatsink.
Yeah.
So yeah, it's surprising when you actually look at what these things are. In fact, we went through that exercise with my CNC of looking at how much torque. It still was very little.
Yeah, like a quarter 20, I think it's like 6 foot-pounds or something is like the max for like a grade 5. Grade 8, you can go a little higher, but like 6 foot-pounds is not a lot. Like you can with a ratchet, you can easily put like 40 to 60 down.
Yeah.
So.
Yes, tight and over tight is fine.
I wonder what would it be. like a human like you and me can probably break a 7/16 bolt with a ratchet.
What tool? With a regular size ratchet?
Regular size ratchet, which is, about an 8-inch ratchet.
8-inch, yeah.
Half-inch would be pushing it.
Yeah, I mean, you'd have to really crank on it, but yes.
Yeah, half-inch would be pushing it, because that's like 76 foot-pounds. I'm just thinking what I've broken before. Yeah, because, like, look at this. 9/16 is 109 foot-pounds. That's, like, max.
Well.
So you probably need to go, like, 1 point. I guess we can look at the shear.
Is that absolute max, or is that the torque to get maximum?
That's maximum rated clamp load.
Okay.
To get to
but that's not ultimate strength of the bolt.
No, ultimate strength is going to be like 1.5 over that, probably.
Yeah.
Or 1.25.
Yeah, there's some safety margin.
Yeah.
For all those people just reefing on bolts. Or it's just going zip, zip, zip.
Yeah. I mean, that's why, like, lug nuts have gotten so much bigger over the years. Is because that's what happens is people just put lug nuts on cars with those guns and just completely stretch them.
So, technically, if you put the effort in, you could correlate pressure and flow to a particular torque at the head. Like, you could characterize your gun.
They do that in industrial settings.
Yeah. Like, if you had enough data points, you could make a curve of if I'm at this pressure with this flow, then the max torque I apply to a bolt is X. So you could make a torque gun if you knew the characteristics.
Yeah, usually they use what's called a torque stick.
Mm-hmm.
Which, if I recall, is basically just like it looks like an extension, a socket extension, but it has like a cam out feature. I think.
Yeah. Mm-hmm.
No, I'm wrong. That's not how they work. They work by harmonics. And they work by, like, because those are hammer driven, those impact guns.
Yeah.
And so it uses the harmonics of, like, the hammer and, like, the flexiness of the extension to only apply a certain amount of, like, torque to the bolt. It works-ish.
That's an engineering term.
Which one? Works-ish or flexiness?
No, flexiness.
Yeah, flexiness.
I used the word edge casey at work. I was like, this what we're looking at is very edge casey, and one of the guys was like, I don't know what that means. I was like, it's an edge case. It exhibits characteristics of being an edge case.
Is that new work or old work?
New work.
You're teaching them. Teach them the ways of the podcast.
Edge Casey.
We're going to start making up verbs.
Hell yeah.
Oh, I guess we should start the podcast.
Probably.
Oh, man, excuse me. Oop, I lost my camera.
Yeah, I was about to say you just disappeared.
There you go, I'm back now. Welcome to the MacFab Engineering Podcast, a weekly show about all things engineering, DIY projects, manufacturing, industry news, and exploding rockets. Did we say exploding rockets last week?
I think we did, but we also said last week that we would talk about it this week.
Ah, okay. We're your hosts, electrical engineers, Parker Dolman.
And Stephen Craig.
This is episode 377. So by the time this episode comes out, I'm going to assume our May the Fab event on May 4th went great. So congratulations to the marketing team for pulling off such an awesome event.
Yeah, we've been talking about that for months at this point. So, yeah, I hope there's a really good turnout.
Yeah, me too. Oh, I mean, there was.
There was. Actually, that brings up a good point. We record this podcast on Tuesdays, and if anyone ever wants to join us for the recording, we actually do. We stream the recording live on the Macrofab YouTube channel. So Tuesday evenings at 7 p.m. Central is when we record. And if you want to hang out with us in the live chat or in just the live stream, come hang out with us. And we do answer questions occasionally from the chat. So
yeah, and we kind of do a unintentional pre-show. I think
and
post-show that doesn't get recorded. Like this week, we before the podcast, we talked about smart bolts trademarked, which are like torque indicating bolts, and just super fascinating.
It's always a random topic. I mean, it's more random than what we do in the podcast. So
yes,
sometimes we've gone on like hour-long chats about video game design and I don't know, just everything.
Yeah. All right, on with the podcast.
Yeah, so this week I've got a topic that I've been studying recently, and I don't think we've ever even talked about this on the podcast. So I wanted to talk about electronics and radiation. I don't think Parker and I have ever had a need or anything driving us to talk about it, but it's something I've been studying recently. So yeah, when it comes to designing electronics, there's stages that you go through in terms of thinking about how your circuit operates. And for the most part, you start with just like the circuit just needs to work.
It needs to do this functionality.
Right? It needs to do the functionality. And then you start thinking about environmental effects. So it needs to work when it's hot, and it needs to work when it's cold, and a handful of other environmental things. But certain circumstances, and in space or around nuclear plants or in other environments, you have to start taking into account that your board is going to get irradiated with particles or just anything really, and that's a whole nother just can of worms that you get involved with, because your thing still has to work, and it still has to work across temperature, and now it's getting pummeled by a bunch of particles,
high energy particles,
and that brings a whole new set of criteria that you have to deal with. So I've been studying a bit of that recently, and it's absolutely fascinating because I've never had to deal with it, so everything is new. If anyone wants to look up information, the Radiation Handbook for Electronics, which is written by, well, it's a Texas Instruments white paper, basically. It's a whole document on it. It's like, I don't know, it's 100-something pages of just tons of information about what happens to your electronics when they get hammered by radiation. And it has a really great intro chapter on like just a primer of radiation as a whole. So I've been kind of digging through this book, and I thought it'd be fun to talk about. So radiation comes in a bunch of different flavors.
Banana.
Grape.
Apple. Grape.
but no. It's radiation. So all of them are spicy apple and spicy grape.
Oh, spicy.
Yeah, so radiation comes in a bunch of different flavors. And depending on what you're dealing with, it'll affect different electronic components differently. So you can't just think of it as like one giant beam of stuff that all just hits your board and you can expect what happens. It's, this type of particles at this level affect this type of component with these failure modes. And so you have to come up with basically this giant, compliance matrix of these are the type of parts that are on my boards. And if we expect this to happen from these, then we can expect this kind of failure rate.
So you can even characterize by radiation type what kind of failures you have to guard against.
Yeah, correct. And and it depends also on the way your parts are manufactured. So something made of silicon is going to respond differently than something made of gallium nitride or whatnot. So it there's lots of layers to this, and I'm in no way do I have any authority on this. I'm so very new to this. So in me explaining all of this, I'm sure we have listeners who are a lot more of an expert than me and might yell at me for giving false information. But I'll try my best here. So when it comes to failure modes from radiation, they're typically called SEEs or SEUs, which stand for single event errors or single event upsets, and I'm pretty sure that those two terms are used interchangeably. And so depending on the way or what kind of test you're applying to your board, you can see different failure modes based on what the circuit is doing. So take for instance something like CMOS or memory or something like that. You might see a bit flip, and that might not be a damaged memory cell. It might just mean that energy was imparted upon that cell that caused that cell to flip. It didn't damage it. The cell can still be read and written to.
It just has it now has a memory error though.
Correct. Yeah. On top of that, it's important to note that almost all of this is probability. None of these things are guaranteed. I mean, given enough time, you're guaranteed to see some kind of effects in certain situations. So, but it's not like something where you can say with certainty that XYZ is going to happen, because it's relatively random, and then that event has to actually happen. So when discussing all of this, you have to say, under these conditions, after X amount of time, we're going to expect these kinds of failures, and then you build risk analysis based off of that. So yeah, single event errors can be either permanent or non-permanent. So you can get things like in analog circuits, if you have, say you have an op amp and it has some kind of DC output on it, you can actually see like a short dip in the output, and it's like a short hiccup that happens. It can recover from that, but something inside gained energy, or something happened to one of the transistors inside, and it has a quick hiccup. That would be a non-permanent thing. Now, with other devices like MOSFETs, you can actually get to the point where you can damage the gate, and you can have a latching situation where a MOSFET can latch on or off. And it's funny because in high radiation environments, or environments that are going to have sustained radiation exposure, FETs are actually not used much because they're far more sensitive to radiation. So BJTs are like the weapon of choice for radiation environments, because it's the gate inside of a FET is very
thin.
sensitive and very thin. It's not very hard to get a particle to punch a hole through it. And at the same time, there's really interesting effects of, you can actually get doping problems in your silicon due to radiation imparting different, like affecting the doping of your P and N junctions effectively. And radiation can also cause whole electron pairs basically to exist, so you can build up charge inside of your junctions due to sustained radiation, and that will slowly alter the characteristics of your device until you turn them off, and you can actually bleed the charge off eventually. So I don't know, I'm rambling a bit here, but there's, outside of your regular design criteria, radiation adds all of these weird things. So it's interesting. There's a lot of tricks that you can do, like for example with that analog example I gave with an op amp that just has a hiccup. You can add some analog filtering to kind of mitigate that or to get around it. So in circuits that go into radiation environments, you see a lot of these extra components lying around. There's like, why would you do that? And most of the time, they're avoiding issues like this. So CMOS digital stuff ends up being fairly problematic because it's pretty easy to flip a bit. And that might not be a problem, or it could be terribly problematic. So, flash memory can be an issue. That's why in radiation environments, you run into things like MRAM, which is magnetoresistive RAM, which is hardened or it's resistive against radiation effects. In fact, this is an interesting or a good time to bring up the words rad tolerance and rad hardness, or radiation tolerant. Before I started digging into this, my knowledge of what it meant when a component was rad tall or rad hard was that it was just extremely expensive. Like that's all I really knew about. Like you would go to TI and it'd be like, we have this $1 part, or you can get it in the rad tolerant version and it's $800.
Yeah.
And mainly what that means is that they've been tested, those parts, and they're guaranteed, or they have test data demonstrating their
robustness.
Robustness. Now, at the same time, that it may also mean that they have different packaging. It may also even mean that they have different wafer level changes to them. So it doesn't just mean we took this regular part, tested it, and gave you the test data. It may physically be different to be more robust. But anytime you do something special like that, it obviously adds to the cost. So it's one of those situations where if you know you need it, and you know how much it's going to cost.
Mm-hmm.
So
do you have any information like what they do to the packaging to make it more robust?
No, I don't. Not off the top of my head.
Okay.
I would not be surprised if that was in the radiation handbook in this TI document. So I could check there. I mean, a lot of times you get away from the plastic encapsulations and you start going into the ceramic stuff.
Okay, yeah.
Or
so metal
there's
cap.
Shielding. Yeah, there's shielding involved. There's different, I think, wire bonds involved in things. And then I haven't read too deep into it, but like I said, the actual silicon changes. There's different processes they can use, and different methods of which they create, like the PN wells and things like that, makes it inherently more robust. And then different materials other than silicon have different radiation properties. So maybe this part comes in a different, 11 herbs and spices, and that doesn't have as many issues.
Yeah, I guess you can use a different doping agent or something like that.
Yeah. Well, and here's the thing that's interesting. It's all there's no part that is just across the board gonna work. You pick them based off of what your mission requirements are, right? So if you're, let's say you designed a CubeSat and you wanted it to live for 3 months up in low Earth orbit, that's one thing. If you wanted to take something to fly to Jupiter, spin around, and then go further, that's a totally different set of requirements, right?
Yeah, because I know a lot of CubeSats, because their lifespan's not very long, and they're actually really close to the Earth, where like a lot of them just run like cell phones and stuff. I know some have like custom hardware, but I mean cell phones seem to be actually just fine being at that altitude for a couple weeks.
Well, the Earth still provides a bit of shielding even at that level. NASA, you can go to NASA and look up they have charts on, if you're this far away or if you're at this, altitude, this is the kind of radiation you'll expect to see. And so that's all data that you can look up. Now, I don't know. I was discussing it with a friend the other day, but I don't know if that's averaged, because the sun can, burp and change that significantly.
Oh yeah,
those numbers. So I think those numbers are pretty average for solar events and things like that.
Yeah, because I do know that like people send just regular commercial stuff up on high altitude balloons.
Yeah, and it's all about like I was mentioning earlier. There's probability for all of this. If you let it just sit there forever, it will die. It's just like that's
Yeah.
guaranteed. It will die. But like, can it withstand a few hours? You know, eh, in a stranger question, like if you go up there, can you sustain a few hours? I mean, the answer is of course yes. So sort of the same with electronics.
Yeah.
So it's interesting because there's like take for instance, I mentioned if you were going to go on a mission to Jupiter, uh, you're gonna withstand a significant amount of radiation for a very long period of time, and that so over time your probability is a lot higher of you sustaining some kind of an event or an issue.
And
And so
doesn't Jupiter itself like emit a lot of different radiation as well?
doesn't everything like I mean,
Yeah, I mean everything does, but
yeah.
Jupiter
It
itself has like some crazy stuff like that too.
wouldn't surprise me. So a way that these things are kind of defined on a mission basis is with TID is what they call it, total ionizing dose, which is kind of like a cap. Cap isn't the right word, but a mission might say, if you're gonna do X, Y, Z, and this doesn't necessarily just apply to space. There's plenty of radiation sources on the Earth, so if you have something that needs to withstand radiation events, you can define your total basic time on your total ionizing dose. So you can say this many kilorads is what I expect these electronics to be able to withstand. And that kind of radiation is long term and it's consistent. And the effects of TID are less damaging in terms of being instantaneously damaging. They're very slow degradation of your electronics characteristics. So take like a BJT transistor, for example. Over long periods of time, the base current or the gain HFE, whatever you call it, on a BJT may very slowly degrade, and it will be a permanent change as it gets irradiated, but it may take a very long period of time. So you can kind of decide based off of your TID, your total radiation, and the rate at which you're receiving that radiation, can your circuit withstand that? And then you start to design around that. Like when you say, I'm turning this BJT on, you might turn it on, I'm using air quotes here, you might turn it on extra hard such that as it degrades, it remains on. Both N-channel and P-channel FETs, they start to degrade such that N-channel FETs turn more on as they get irradiated, and P-FETs turn more off. So if you have a P-FET, you just keep irradiating it, eventually it will just not ever be able to turn on.
I imagine the gate leakage would start going way up too on MOSFETs.
Basically, what I've been reading is like the characteristics all just get worse. Like everything just
Yeah.
gets worse.
Nothing gets
So
better.
You have to design around that. Yeah. You do. But that's like another level of design criteria you have to keep in mind, because it has to do this over temperature as well, right?
Yeah.
So everything starts to get a lot worse, and so if you're designing with radiation in mind, like what is your circuit currently doing, and if you degraded all of your characteristics, would your circuit still work effectively? And what's interesting is that the TID, the total ionizing dose, the way you test it is you just say, here's my limit. We need to test from 0 to X amount of radiation. And you do that over a period of time, and you take data points, and you just basically plot how bad your circuit is.
Yeah, you plot the characteristics and how they change.
But what kind of sucks about it is some components respond differently at a higher rate than a lower rate. So TID just defines the total amount of radiation you're getting, but it doesn't tell you how fast you're getting to that point. So you can do different rates while you're getting to that maximum limit to test different characteristics. Like, I can't remember exactly what it is. I think BJTs exhibit more issues when they're at a lower rate. They actually get better when they're irradiated higher. Don't quote me on that. I think that's it. There's another component that gets worse as you go higher, which is what your gut would think, right? But one component gets better as it gets more irradiated, or I shouldn't say better. It just exhibits less problems. So there's a different way of executing that test that's called ELDERS, which is enhanced low dose rate sensitivity. So as you're tallying up to this total amount of radiation, you change the rate at which you're doing that, and you look at your characteristics of the components as you do that, and basically just plot it out and say, yeah, I can survive, or nope, get a new component.
Yeah.
And this is all super. I don't know. I'm really fascinated by this now, just having to dig really deep into it, because I've just never had to deal with this. One of the things that's interesting is in the actual physical testing of devices. You irradiate the hell out of a device. That actually heats up the device. So you have to irradiate it, and then you have a cool down period before you can go and do your testing. I don't know. It's interesting. So there's also two other. So TID just is total ionizing dose. So you got gamma, you got beta, you got X-rays, you got alpha beta particles. It's just like everything. Just throw it all at it at whatever rate you need for that test. But there's also proton and neutron testing, because, like I said earlier, there's different flavors of radiation. Protons and neutrons have different effects that they damage components as well. So yeah, you have to design around all three of these characteristics. Well, I mean, you design around what the mission requirements are, but
yeah, and I could imagine too, like, it's like the problems in testing there is just this. It's almost impossible to test for everything, because you might get different mixtures of all these different radiations as well.
That's right. Well, that's why your mission requirements, you start at the beginning and just say, what is this thing going to be going through, and what does it have to pass, and just test for that. Because you can go crazy trying to test for everything. You can just go nuts, and you can spend an unlimited amount of money effectively. Because even parts that are labeled rad tolerant or rad hard are not impenetrable to this.
Yeah, they're not radiation proof.
Yeah, that doesn't exist. So those are just parts that have been qualified and shown to be much more robust. But
still
that
got to test them.
Necessarily mean that they're impenetrable. So I don't know. That's kind of a bird's eye view of what I've learned in 2 weeks of studying this stuff. It's fascinating. I'm really excited to go further, because this is just a completely untapped area of my knowledge.
Well, I look forward for what you learn in the next 2 weeks.
Yeah, we'll see.
So speaking of space and radiation, well, not really radiation, I guess.
This didn't get all the way to radiation.
No, it did not.
This got to sub-radiation.
This happened a couple weeks ago, but we kind of been busy with other things in the podcast, because I think we had a guest and then we just didn't get to the topic.
Yeah.
Maybe we should switch that around. Maybe we should switch to like the news things come first in the podcast.
Yeah, maybe.
Instead of doing them near the end where we sometimes just don't have time to do it. But anyways, this is the SpaceX Starship. I actually woke up early that day to watch it on YouTube. What was there?
Watched it live?
Yeah, I watched it live. It was they had some bullet points like they were like, all, this is like a test flight. If it clears the tower, like basically if it gets off the ground, they're like, we're good, like we're happy. And then like the next bullet point was like, guaranteed to entertain, was like bullet point 3 or something like that on like
these sound like Kickstarter goals.
Yeah.
Or stretch goals.
Yeah, but I just like how like in the news, in like the press release, I guess is what you can call it. Like that was like bullet point 3 was like it's gonna be guaranteed to entertain, and it did. It just like when it first launched, it was just insanity of the noise it was making, and I wish I was down there in Boca Chica to watch this thing. God, that's like 8 hours away from Houston. It left the same coast I live on, but it's 8 hours away.
This ship was absolutely gargantuan. What, it was 40 stories tall, something of that?
Yeah, something like that. Yeah. It's the largest and most powerful launch ever flown. Now it didn't get to orbit, so it's not the most powerful rocket to get to orbit yet, because that would be still the Saturn V. But it was the most powerful one ever. Like they lit it off and it went. Because there's been rockets.
It left the launch pad.
It left the launch pad. Even with the engines down, like it had like 3, or I think it like left with 3 down, and like 6 others like blew up going up. So
didn't it have like a total of 39 or something
it's
like that?
Something like that, like 36, 39 rocket engines.
And I don't remember the count, but there's like there's a radial grouping of them that are not movable, but it had they could actually direct vector they could direct the nozzles, which is nuts.
Yeah. But yeah, the launch was great to watch. Apparently they completely destroyed the launch pad. Cause that was actually one of the things is they were like, we want it to clear the tower so it doesn't damage anything, and it still just damaged everything. And
was the tower destroyed?
No, the tower was fine. It's just like the little like pizza stand that they made to kind of hold the rocket up on the bottom.
It just roasted it.
Yeah, all the concrete just got... Actually, if you watch the videos of it, you can see ginormous chunks of concrete being thrown... And, like, this rocket's 40 stories tall, and it's throwing big blocks of concrete, like, that high up, and then away from it.
Yeah.
So you gotta think is, a lot of the, probably, engine failures are probably from, like, it just throwing debris everywhere before it started moving. But it's just
this is real world Kerbal Space Program.
Yeah, I definitely would agree there. Kerbal Space Program, just keep adding rockets and boosters until you make it to orbit, right?
Yeah, that's totally it.
Really cool launch. I'm really looking forward to like if they can actually get to. So apparently, like this is like an older generation of their rocket already. Like they already had like the new stuff is like ready to go basically, but they had to like rebuild the launch pad and stuff. So we'll see how quickly they get the second launch off. But yeah, should be cool.
I think. Okay, so for those who don't know, the ship didn't make it to orbit. It did explode.
Yeah,
and I think. I feel like people are being very unfair to SpaceX and basically calling everything a failure. And in this situation, that is absolutely not a failure in my opinion, because the valuable data gathered is, well, valuable. It's this is certainly not a failure, and they already broke a ton of records with doing this. I mean, this thing is absolutely enormous.
Yeah, I guess a lot of the negativity is probably directed mainly at like Elon Musk is an egomaniac, to put it lightly, and so that's probably where a lot of the negativity comes from. But the whole like when you look at their mission goals, like it was seriously like, will it ignite and like lift off the pad? Was like they had this whole like if it got into orbit and that like actually I think they were going to kill the engines before it could even get to orbit. Like they didn't want it to get to orbit.
Oh, okay. They just want to get it off the ground.
Yeah. Actually, I think the second stage, which is like the capsule part of it, like they wanted to test the because it's supposed to be like a glider, like it like belly flops down, and it was supposed to belly flop near Hawaii. So it's going to go like 90% or like 80% around the Earth was like the entire mission goal. But they're like, first thing, if it gets off the pad, that's a success. Like they haven't said that, and then people are like, oh, it blew up after the pad. And like that's what they wanted to do, though.
Yeah, I'm actually watching the video here, and it just exploded, and people are just cheering, and they're super elated.
Yeah, like everyone that was part of it was like, the fact that it actually ignited and it worked, and it just didn't immediately explode or immediately lose control. Now they got a lot of things to work on, clearly.
A lot.
But people forget, like, I think a part of the also problem with this is people are also expecting, like, Falcon 9 launches and landings of the boosters are so routine now. Like, I think there was like a Falcon Heavy launch that happened like earlier over the weekend and didn't really make too big of a deal. No one made a big deal about it. It's just
whatever now.
Yeah, it's just like whatever. So I guess that's maybe where some people are also coming from, is rocket launchers from SpaceX are so routine now that this was not a routine one.
Yeah, they're not blowing your mind.
I mean, it blew my mind. Just like, this is the sound of that rocket going off. I think the next test flight I need to go down there and camp out.
That'd be cool.
And just
you could probably camp out really far away and still hear it.
Oh yeah. That'd be so cool. I gotta go figure out if I can get that to work. Swing that, go down there and go camping. You know, I bet you.
I'm trying to look up how. What is it? 129 decibels was how much it was.
I bet you it was louder than that nearer to it.
Yeah, I actually. Sorry. 1.5 miles away, it was 120 decibels.
Oh, jeez.
that's hearing damage 1.5 miles away.
Yeah. No wonder all that.
It's up to. NASA's measurement captured the launch noise at 204 decibels. That was probably close.
Yeah,
too.
probably at the pad or near the pad.
Yeah, at the pad. Yeah. That's ridiculous. 200 decibels. That's like not hearing damage. That's physical damage to your body being close to it.
Yeah.
Yeah.
The shockwave will probably liquefy your insides.
Yeah. Jiggle you around a little bit. The biggest one-stroke engine ever made.
Biggest one-stroke? I guess so.
I think AVE on YouTube calls them rockets that one-stroke engines.
I guess technically, yeah. The thing is, they got a lot of moving parts with them now. I guess that's not the whole point of one-stroke, two-stroke, four-stroke engines, though.
You know, one of the most interesting aspects of rocket engines for me isn't just that. Well, like one of the interesting things is how they deliver the fuel fast enough.
Yeah.
Like, you just have to get a massive volume of fuel to the nozzle. It's not the fact that, like, blowing up rocket fuel is not that hard to do, but delivering it is ridiculous.
Yeah, the big old turbo pumps.
Yeah.
Yeah, you can't just let gravity feed it.
No, it won't go fast enough.
Yeah. So
you have to force it into there.
Yeah. So you have like a miniature, maybe not, these might not be SpaceX engines, but I know some of the engines have like miniature combustions to spin up the turbine. And then when the turbine's spinning up, and then you can ignite the main nozzle. And then the main nozzle, the effect basically can spin the turbine even faster and get the fuel delivery up.
Yeah. And the old Saturn V, what were they? V1 were the rocket engines?
F1.
F1, that's it. Yeah, the F1. They pumped the fuel around the cone as coolant to the cone.
Yeah, I think a lot of rocket engines actually do that.
Yeah.
But yeah, Yeah, to keep the nozzles from melting, basically. You can the cryogenic fuel. You can just cycle it around the outside, and it will just burn it. So
Man, the last time I drove down by NASA, I was a bit bummed because it used to be that the rocket was just there, like you could just
yeah,
look basically from the freeway and see it. You know,
yeah, they got a
now
lot of
it's in a big old warehouse.
yeah, they got a lot of flack for that though. But just leave it was awesome just it being outside because you could really appreciate how
drive
big it
by
was.
it.
Well, no, you can just appreciate actually how big a Saturn V was because you could just walk back and like you could actually look at the whole thing. Whereas now it's in a big building, and so
You can still visit it. It's not,
Yeah.
you know.
yeah, you can still go visit. Actually, there's a picture of me of like standing at the business end of that rocket engine and pointing at it. And it's like one of those engines is like twice as big as me.
Oh yeah.
But you can't walk back, and the only way you can appreciate the size of it is to go outside and look at the building and see how big the
Yeah.
building is, which isn't the same. So you have to be inside, and like you're like the farthest away you can get away from it is like 30 feet, and so you like it's just big rocket in front of you, and you can't really appreciate how big it is. That's actually the same problem I had. This side tangent here. When I went to the National History Museum in New York City, with all their fossils and stuff, they has like if you haven't been there, you have to go. Like that's a great museum. But the problem with that museum is there's so much stuff in that museum that you go into a room and you're just on top of everything. And they have like this big T-Rex, and you just can't appreciate how big the T-Rex is because you're just like right on top of the T-Rex. Like the max you can get away from it is like 4 feet. And so you like look you're like looking straight up at the T-Rex, where I really like the Houston Natural Museum because there's so much space there. And so you can really like take a couple steps back and really appreciate how big some of these animals were.
And the entrance to the museum is the T-Rex.
Is
It's
the
right
T-Rex,
there.
yeah.
And that room is huge.
Yeah, that room's ginormous. So you can really see how big this animal was. Now, the New York Museum has so much more stuff in it, though. So, like, it's definitely a place you should go. It's just, that was just one thing I was shocked at. Like, I'm so used to, like, the Houston museums where, like, there's so much open space. But then you go to the New York one, it's like, oh, like, you're, like, huddled and, like, walking in between people to move around and stuff. I would definitely go back, though. The subway station for that museum is pretty cool. They have, like, their own custom subway station.
Oh, of course.
Yeah. So, yeah. I guess we'll talk about the SpaceX launch whenever they do the Starship again.
I was just reading something that they were potentially going to do one like really soon in the next few weeks.
Oh, I thought it was supposed to be like 2 months, 3 months.
I could be wrong. I just, like I said, I just kind of glanced on something like that seems really, really soon.
Yeah, especially since they got to rebuild that whole like pad.
And the rocket.
Yeah. Well, no, they already have new rockets.
Yeah.
But I do kind of like think it was like SpaceX is they in this case they were like, okay, this rocket's obsolete. You know, we either launch it or it goes to the scrap heap when we take it all apart. And I'm just so glad they just said, screw it, we're launching this thing.
They probably have a whole document that's just Operation Send It.
Yeah, just the page 1, send it.
Yeah.
It's just something that I kind of appreciate of like just raw. You're right. They got so much data from the flight, and just so
It's
much
worth
raw
it.
like
It's totally worth it.
just like it's a different kind of engineering, right? We're like Boeing and NASA have to do so much testing and simulations to make sure everything's going to function correctly because they're paid by the taxpayers, right? And the Senate, I guess Congress
Congress, yeah.
sets their budget. Whereas like SpaceX is like they can take a swing at it.
Yeah, it comes out of their pocket.
Yeah, I know they do get a lot of like flights from NASA and the U.S. government themselves, but it's still a private company that they can go bankrupt. So
I don't think they would ever let me be in charge of launching a rocket because I would just have a big red button that says "yeet" on it. Slap that.
it would be kind of cool.
I heard the other day that the whole countdown sequence thing
Yeah.
is totally an American thing. Like only the Americans do that. Apparently the Russians just have there's just a time that it's supposed to go off and they don't count down. It's just when the time happens they just launch. So that just the whole countdown sequence. They continue to do it out of not nostalgia's not the right word, but it's just like
Tradition.
it's just what we do. Yeah, tradition, I guess. So
I guess that makes sense. That makes way more sense than doing a countdown.
what, just having a preset time?
Yeah.
Well, I guarantee you we have a preset time as well. It's just what's the purpose of the countdown? I don't know.
The purpose of the countdown is hype.
Yeah. I just thought that everyone did that. Nope.
Yeah. All right. So, do you have anything else to talk about the Starship?
No, other than it was really cool.
Yeah. I did get to watch. I did watch the Falcon Heavy as well. Because I think that's like the third flight or second flight, something like that of it. And it's like we put 3 Falcon 9s together and launched it. It was pretty cool.
Just duct taped them all together.
More or less, yeah. Science duct tape that's rad hardened.
Yeah, that's science tape.
Science tape.
Actually, I bet you that's a thing. I bet you space tape is a thing.
There is a 3M has a tape that has like space ratings and stuff.
Oh, I'm sure. And now I'm gonna look it up. Space tape. Well, okay, so that's just a commercial product. Duh, of course it is.
Yeah,
what
3M tapes for aerospace. It's like something in there.
Okay. And okay, so I bet you tape like that for aerospace applications is probably just, I shouldn't say just, but it's going to be tape that has certifications behind it and testing. Whereas, you go to Home Depot and you buy gaff tape, it's just, well, this is sticky stuff that, it's just going to hold together. It doesn't need to be certified.
Mm-hmm. All right. Last topic for today. So this topic kind of came about. I was talking to Mashal, who's our marketing director, if I want to say. He's got some position like that. He's the lead of marketing at
High
MacFab.
up marketing.
Yeah. And he sent me a like event that was happening here in Houston. And it was they were doing like a kind of like an in-person webinar, I guess. Not like training though, like a class maybe.
Info session.
Info session. There you go. That's a big old catch-all term there. I like that one.
Yeah, that's marketing.
Yeah, an info session on designing and manufacturing a PCBA. And I'm like, this is great, but it kind of got my brain moving on what kind of... So this is like definitely geared to like engineers that are out of college, that are working at startups or they're fresh engineers. Okay.
Well, that topic in particular.
Yeah, that topic in particular. And I got to thinking of how many times have you sat through, because I know I've sat through a lot of these, like sat through introductions on topics.
Oh, a bunch.
Especially like how to
bunch-
design a
bunch
PCBA.
earlier on in my career, for sure.
Yeah, earlier on in your career. But I got to thinking of like what kind of topics and discussions would like a senior or a principal engineer would like care about. Because like someone like you or me wouldn't go to a how to design and manufacture a PCBA. We wouldn't go to that kind of event.
I wouldn't. Yeah, I wouldn't put the time in to do that because I just don't feel like I would need it. Now, I've been to these kinds of events where they talked specifically about troubles with switch mode power supplies and designing your own, and they went into testing on it. That was fantastic. In fact, that was like a 5 or 6 hour thing where they went through different, design chunks,
Topographies and stuff.
and then did how to simulate them in PSpice. And so I think that's a great. What's funny is I went to that when I was a fresh engineer. I was like out of school, maybe a few months. I went to one of those, and there was senior and principal level engineers in there, and so that I think that's an example. Like when you start getting into those topics that are specific, that's what they're
So I see what you're saying. So basically, like becoming more specific on topics that are more advanced in design.
Absolutely.
Which does make a lot of sense.
But the second you start doing that, your attendance rate plummets.
Yeah, well,
You're going to get those 2 or 3 guys who really want to know that one thing.
well, yeah, and there's not a lot of electrical engineers out there, right? Comparative and like engineers in general, like electrical engineers that's a small pool, and then it's like okay, engineers that also design switch mode power supplies that want to learn an advanced topic on those. You're talking in smaller slice of the pie.
Yeah, exactly. Whereas PCBA, you're shooting a dartboard with a shotgun with that one.
Yeah, that's like almost probably half of electrical engineers probably do PCBA stuff.
So, actually, sort of in relation to that, remember when both of us went to DEF CON a few years back, we both attended a handful of lectures, and those lectures were super random. There was a bunch of random stuff, but they were like really nerdy and very specific. Those lectures can kind of only exist at a place like DEF CON because you had 40,000 people, and out of 40,000, the rooms we were in still only had 50 people in them. In order to get 50 people, you had to have 40,000 people there.
Show up. Yeah.
Yeah.
Man, that just brings me back to that whole DEF CON. Because, like, for example, there was a talk. The talk I went to was using image processing, because I'm half my degree was like in image processing. So I'm like, image processing, that sounds interesting.
Yay.
But it was image processing to analyze malicious payloads like viruses, basically, or like malware. Like basically look at the data structure as an image to see if you can determine if it was malicious or not. So it's like this kind of roundabout way. I'm like, that sounds super interesting. And it was a 45-minute long talk, and the answer was no at the end. You can't do it. It doesn't work.
Right, yeah.
And I was like, that
so
was
hyper specific, right?
Yeah. I think there was like 40 of us in the whole room.
Yeah.
And I thought I'm like, this is super interesting kind of stuff. And the great thing is the answer was no. It doesn't work.
Okay. But here's the thing that what I think that's so funny because this ties back to the SpaceX Starship. It blew up, but now you know.
Yeah.
Right?
Now you know.
And so it's valuable still.
Oh yeah, it's super valuable. But yeah, I think you're right. Is DEF CON works that way, or events like DEF CON work that way because you can get 40,000 people in one area, and then you can do the hyper focus where it's going to be 50 people out of that whole group that's going to show up and like take something from that talk. Now, now they also have talks that like in the main floors that have like 2,000, 3,000 people in those talks.
Yeah, and those tend to be a little bit more of the like the pop talks and like the really like flashy kind of stuff, which those are fun to attend. Now, anytime I see like an event of this sort where they're talking about a very generic topic, you always have to ask yourself, is there an agenda behind this? Because a lot of times they're put on by a company that like at the end they're trying to sell you software or something of that sort. And this doesn't end up being a how to design or a PCBA, it's how to design a PCBA with our software or something like that. Yeah, and I think engineers have a sniffer for being able to smell that kind of stuff. So you're already trying to get people who are weary about those kinds of things to come to your event. So yeah, and so for the senior or principal level engineers, it's going to be a lot harder to find a topic that they're willing to break away their valuable time to go, because there's a much higher likelihood that they're advanced in age, advanced in their position at work, so it's harder to peel them away to go visit something. There has to be a really good reason. Whereas when you're younger and you cost a lot less and you might not have children yet or all these reasons, it's way easier for your company to be like, yeah, go attend this and learn. You know?
And I was also thinking about this as kind of like my experience as I've gotten more advanced in my career. The going to Maker Faire. I used to go to Maker Faire, like I started when I was in college, and I would go to like a couple Maker Fairs a year. I would go to like the New York one. I'd go to the San Mateo one in California. I'd go to the Houston one, and I kind of stopped going to them because one, it was it was like you might find one or two new things every single time, and a lot of times it was kind of the same stuff all the time, and then it ended up being okay. I'll go because my friends are going, and then your friends stop going, and you're like, okay, there's not really a point for me to go to these Maker Fairs anymore. Whereas now I go to I basically replaced it with DEF CON, because DEF CON is kind of flipped around, right? Where you go to DEF CON and you don't even know what talks are going to be there yet until like you show up and you go, oh, these are some crazy stuff.
I wish there was a double E version of DEF CON. There's double E things at DEF CON for sure.
Oh, hardware is like actual hardware is still very small at DEF CON. It's a lot of mostly software.
Yeah, I mean, there's plenty of soldering, but what I mean by this is a lot of the hardware stuff ends up just being soldering little kits or things like that. And, not digging on that, but there's not a lot of hardware meat.
Mm-hmm. Yeah, on the hardware side, it's a lot about like learning about how to hook up stuff so you can attack the firmware or something like that.
Yeah, it's the setup for the software.
Yeah, no, you're really right.
Yeah,
there's not a lot of like it's starting to become more of a thing where like physical security is being treated better at DEF CON, that kind of stuff. Because that's the same thing. It's DEF CON is almost like a security conference almost. So physical security is hardware.
I would say it's not kind of. It totally is a security conference.
Yeah.
Or an anti-security conference.
Yeah. Well, I mean, you learn a lot of attack vectors and stuff like that. You start thinking about that stuff more going to those events.
Man, if I could go spend like 3 or 4 days where I wake up and go do a topic or hear a lecture about switch mode power supplies and then go do some analog stuff and then, just go see a bunch of topics on double E, like hardware design, that'd be awesome.
I wonder how hard that would be to put together.
Hard. I would think it would be hard. It would probably be hard to find the right people to teach it, because it would be great to get people from industry to do it as opposed to just a bunch of professors. And
Mhm.
that's not saying bad things about professors, but it would be nice to have people from the trenches teaching.
'Cause I did go to Particles conference a couple years back,
Mm-hmm.
and that one was pretty good. It was a lot of hardware focused classes and that or talks. I like that one a lot. Unfortunately, I think they stopped doing it.
Well, what I think what it really could be is if DEF CON expanded more into hardware, you could marry the two.
Oh yeah, and it's getting more and more hardware. It's just its heart is hackers, right?
Well, and that's just the thing. The hardware aspect of DEF CON is mainly hacking. It's
Mhm.
not designing your own circuits or things of that sort.
I see what you're saying. Yeah, I can agree there.
I've seen a handful of like the larger talks, and they go pretty deep into hardware.
Mm-hmm.
In fact, and there was a guy, was it last year or the year before? He had a whole talk on how he manufactures his own vacuum tubes, and that had nothing to do with security or whatnot. So yeah, those kinds of things do exist there. Yeah, I would totally, if it was really hardware heavy, I would consider attending every year for sure.
So, listeners out there, if you are a senior or principal electrical engineer, post in our Slack channel what you care about. What kind of class would you go attend? I do think Steven is right. It's you start becoming more specific in your topics, and or start focusing more on certain aspects of stuff.
So
But
you'll attend based on if it's your specialty or if it's your passion project.
true, which is kind of weird. Where like, how do you get? It's easy at DEF CON or easy at like events like that. Man, that'd be so hard to do. Like something the size or scale at DEF CON, but just like hardware.
That would be really hard, but that would be fun.
Yeah. Maybe someday. The Macrofab Engineering Podcast Conference.
I mean, the May the 4th, which is happening in 2 days, maybe something like that kind of evolves into
Maybe.
something a little bit larger.
But yeah, if definitely want feedback on it. So yeah, post in our Slack channel, which is macrofab.com/Slack, or just shoot us an email, podcast@macrofab.com. Yeah, I guess we should wrap this up. We're almost at an hour.
Somehow we made it.
We do every single week.
Every week.
So that was the Macrofab Engineering Podcast. We're your hosts, Parker Dillman.
And Stephen Craig,
Later, everyone.
take it easy.
Thank you, yes, you, our listener, for downloading our podcast and listening to us speak for an hour every week somehow. If you have a cool idea, project, or topic, or some like, how would I get you to show up at a meetup in Houston? Tweet us at MacFab, at Longhorn Engineer, or at Analog ENG, or email us at podcast@macfab.com. Also, we have that Slack channel. It's macfab.com/Slack. Can't find the mouse button.